Okay, so the top of this page here will finish up. Again, they want you to use that same formula. So from letter F, oopsie, we got stuff going on. Sorry, when you have a touch screen, got lots of things going on here. Okay, so the formula for the previous page was what? Negative 4.2u, and then plus what? 44.9. And so again, if it's 5%, you don't move the decimal on this one. They just want you to put in like 5. Okay, so you kind of have to know what your variables are and what they're subbing in. So then order of operations, you're going to sub in a 5 here where the u used to be. So you multiply first, then add this in there. And so when I do that, let's see, about what, $23.90 per hour. So an unemployment rate of 5% tends to go with jobs that make about that per hour. All right, so we know that, I mean, this formula is great, but we also know it's a model. It's a mathematical model. It's not going to be perfect, all right? And so when we graph these, there's some things going on here. If I graph the actual data, you know, for a scenario, you might have all these dots there. And so my line of best fit might kind of, again, be the average line. And some of these dots are definitely not on that line. Some are above, some are below, which is totally, and maybe 1 or 2 might actually hit it, but they might not. And this is the best fit line. So a computer can do that. But notice that these dots over here are the observed data. The dots that are on the line are like the predicted ones from the formula. And so there's an error, and we call that the residual. And so the residual is when you take the observed, like what really happened, what we know happened, minus the predicted value. That error is what we call the residual. And if you take statistics and you get to residuals, there's a little fancier formula than this, but this is trying to get you to, I guess, get there a little bit or to move in that direction. All right. So go down and look at problem number 4. The formula is at the bottom. Read through it, and then we'll talk about it before I have you work on it. Okay, so if you read this scenario, the professor is trying to figure out if he even needs to give a final exam, or if she never, I guess it's a he, needs to give a final exam, or if they can just predict it. So they have a formula down here, which this is the predicted final exam grade. So not what they really would have earned, but the predicted one. And the formula they have is this coefficient times their overall grade, and then minus that. All right. So if you think of the chart, the overall grade, we know that this is a comma of overall grade. So we're going to put each of those numbers in there one at a time. So we're going to take this, multiply by the overall grade, subtract this, and then we're going to get a predicted final. So for example, someone that has a 72%, we're going to take that 1.0138, sub in that overall grade, and then subtract that 4.1629 and hit enter. And what that's going to do is that it's going to give us our predicted exam score. So I get a 68.8. And so what you need to do is keep changing the variable down here with these values right here and keep getting all your predicted grades. Okay. So, and then after that, then you're going to follow this formula to get the residual. So the residual is when you take the observed, which this is what the observed is the real one. So this is the observed grade, okay, because that's what they really ended up getting on their final exam. And you're going to take the predicted value, so what the professor thought this formula would predict, and you're going to basically, the residual is like your error. How far off were they? So fill out this chart and then fill out this column. And again, this is your formula, and these are the observed right here. That's what really happened, and this is the predicted. So go ahead and get all your predictions, get all your subtractions, and then we'll chat. All right, so if I keep subbing all these values into my formula that predicts the values, you should end up getting these values in this column. And then if you subtract what really happened from the predicted value, you're going to end up getting the residual. And this is something I would put on homework. I would probably put it on the quiz, but you can look up the formula. But I probably would not put this on the test, because in statistics, if you get to residuals, you usually use just a little bit more complicated formula. So, okay, can we get this thing to go back? There we go. All right, so go ahead and pause and answer the questions on A, B, C, D, E on the next page, looking at your residuals here. So I'm going to pause for a second so you can look at those. Okay, so we've already done parts A and B because we predicted them using the formula, and then we found the residual. So let's look at C. What does a positive residual tell you about that student's performance? All right, so let's look at our positive. So this person had a positive. What do we have? Oh, I don't know why I just did that. Can I undo that? There, it kind of destroyed that too, but let's see if we can. So this is a positive residual, positive, 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 negative, positive. So positive residual means that the observed value has to be higher, so I have a bigger number, positive number when I subtract, right? And you can kind of look at that in the chart. So they had a bigger observed value. So that means they actually did better than the teacher expected. What really happened was a higher number than what was predicted. So that's why when you subtract, you still have a positive left. Okay, so they actually did better than they were expected to. D, what does a negative mean? Well, then that would be the opposite. That means this number is smaller and the predicted value is higher. So they actually predicted that the student was going to do better than what they did. So in reality, they did worse than what they were predicted to do. Okay, so they performed worse than they were expected. All right, and then E, how do you think the model, given the equation and the trend line, predicts it? All right, so, you know, should the professor still give the exam? Well, we would want residuals of 0, you know, to if they were pretty close. So like this isn't bad, that's not bad, that's not too bad. We're hovering around 1. But the reality is like this is off by 11, this is off by 19-ish, 15-ish, 4-ish, 4-ish. So a lot of them are off more than, say, just like 1%. So I would say that, you know, it's too far off, and that they probably need to give the final exam. So residuals just kind of tell you what your error is. All right, I'm going to stop there and then go ahead and work on this section.